Hello, welcome to Power System Fault Section 3A. We will learn to calculate short circuit current when three-phase fault occurs at the terminals of a synchronous generator, which is operating at no load. This curve shows three-phase fault current. At the beginning, the magnitude of this current is very high. As time goes by, it will be lower and lower until it reaches steady state period. However, it is still higher than normal current. It could be divided into three periods. The first period is subtransient period. It is very short and the current is very high. The second period is transient period. And the last one is steady state period. For subtransient period, it is very short time. It is less than a second. The subtransient reactance is the smallest value. Therefore, it will produce the largest current in this period. The next period is transient period. It may be a few cycles to almost 1 second. The transient reactance is intermediate. Short circuit current magnitude will be intermediate. The final period is steady state period. The synchronous reactance is the largest one, and the corresponding current is the smallest one. Again, this slide will emphasize three periods. Compare the time of each period. The time is very short in subtransient period, and longer and longer in subsequent periods. Whereas short circuit current in subtransient period is very high and it will reduce smaller and smaller in subsequent periods. The subtransient reactance is the smallest one and it will grow bigger and bigger in subsequent periods. Let's consider in an example. Generator is operating at no load. All parameters are given. First, we will calculate base current by using generator ratings as base unit quantities. Base current is approximately 321 ampere. Pre-fault status. Generator is running at no load. The pre-fault voltage is 1 per unit. Then, three-phase fault occurs at the terminals of generator. We model generator with voltage source and reactance in three periods. The voltage source and reactance change their values with the time periods. Voltage magnitude is 1 per unit for all three periods, since generator is operating at no load. For subtransient period, reactance value is 0.12 per unit. Therefore, the magnitude of subtransient fault current is 8.33 per unit or approximately 2672 ampere. For transient period, reactance value is 0.25 per unit. Therefore, the magnitude of transient fault current is 4 per unit or approximately 1283 ampere. For steady state period, the reactance value is 0.5 per unit. Therefore, the magnitude of fault current is 2 per unit or approximately 642 ampere. Let's compare fault current in all three periods. Voltage is 1 per unit for all periods. Reactance value is the smallest one in subtransient period. Then it grows up bigger and bigger, whereas fault current in subtransient period is the largest one and it reduces smaller and smaller. In conclusions, three-phase fault currents in a no-load synchronous generator operating at rated voltage can be calculated in three periods: subtransient period, transient period, and steady state period. Thank you for your attention. Please stay tuned for more clips.